Hello friends, in this session we are going to see the control flow of a Java program. So here we are going to see first as a static control flow, then next we will see the instance control flow. So assume you have a class, say class A, right? A is a class, and in that you have int x is 10 and it is of course static, and you have one static block, static and SOP statement of, I'll say a static initialization block 1 in class A, and say this block is till this, and then I'll have one more static variable, static int, say j is equal to 20, right? And here I'll try to access the SOP statement of x, and I'll print SOP statement of y, right? And x I'll reinitialize with say 99 and say j, okay, it is not j, it is y, and y I'll reinitialize with 88, right? Then I'll have one more static block, say static, and in that again I'll print SOP statement of static initialization block 2 in A, and print x, print y, and print x reinitialize x with 101 and y reinitialize with 102, suppose, and it continues. So here I'll draw a line first, and assume you have continues, the class continues. Here you have a method void some show method, and show method has to print say SOP statement of, and that is also static. Show method is also static, and it has to print here show method in class A, right? And show method also prints the SOP statement of x, and it prints the SOP statement of y, right? This is show and this is class over. Now you have a class test, assume class test. In that test you have main method void main with a string type array here, and you just call show method here a dot show, right? So this is class test, and in this now you have here this is the console, and when you will execute Java and say test, and when you press enter in the console in command prompt, then how it works and how JVM loads the class and what is the control flow of this class in this show function, right? A dot show. Now so JVM is this is your JVM, and this is the JVM memory. First assume right. So you have so this is the method area in JVM, this is here method area, stack, and heap memory, right? So when you write here Java and test, this has to start the JVM, and JVM requests some memory from the operating system, and operating system gets divided into multiple parts in JVM. So I'm showing here only the method area, stack, and heap. And when you write here Java and test, then test class should be loaded. So this is assume the test class is loaded here, this is test, right? Now it has to start executing the main method. When main method starts execution, main comes into stack memory, and this is here main, and inside the main first statement is a dot show. when you write here a dot show, then what JVM has to do is JVM has to search, okay, what is A, or where is A class has to be loaded. So JVM searches your A class in your workspace, and in your workspace A class is already ready. Then A class has to be loaded. So assume the A class is loading at this place. A class is loading here. JVM starts loading the A class. When JVM starts loading any class, then class loading completion is done in various phases. So it means JVM has to go through the entire class for so many times to identify so many different components, and it has to load accordingly into the JVM. So in first phase, what JVM does is JVM goes through the entire class and it identifies only the static members. And what are the static members available in this class is, you have one variable, so this is first identifies x, right? X is a static variable, and then it identifies one static block, 2 another static variable, 3 another static block, 4 another static method, that is 5, right? So all the static members identified, and when it is identifying the static members for all the static variables, JVM allocates the memory in the method area only at that time. So it is allocating the memory for x, and x gets the default value first time. Even when any static variables are having hard-coded value, the hard-coded value will not be initialized at first time. First time just JVM identifies the static variables and allocates the memory for those and initialize that memory with the default value depending on the data type. So first it got x, and x is of type int, x memory is allocated, and int type default value is 0, so it got 0 first time, right? Then second one is second static block, okay, it remains as it is, not executing. And third, it got a y static variable, so y memory also gets allocated and y also gets a default value, that is again 0. So this is first phase done. Once it is done, all the static variable memory is allocated and initialize that with the default values, and all other static components in your class is identified. Then first phase is over. At that point, this is called as class initialized. This stage is called as class initialization. Class initialization. Class initialization is just identify all the static components, allocate the memory for all the static variables, initialize those memory with the default values, is called as class initialization. So this is first phase is over. Once this is done, again JVM goes to the entire class, and what JVM does in this point is, first time this operation is done and this operation is done. In the second phase, JVM again goes through the entire class and initializes that hard-coded value to the all the static variables if hard-coded values are available. So first time when JVM comes here, this is the 6th. When JVM done is, this is 6th. At 6th point here, JVM initializes that x with hard-coded value. Now x value is not 0, it is 10, right? And in the next run, JVM again goes through the entire class and initializes all the static variable with hard-coded value if available, and also starts executing the static block, right? So what JVM will do is, first from the top to bottom, when it do like this, then first x comes and x value is 10, and text 10 is initialized at this point. Then second one is static block, this has to be executed. So when any static block is going to execute, because it is a block, so block has to be loaded here. This is the static block 1, this is static, and suppose it has a local variable here. I'll take one local variable, say int I is equal to 99, and I'm writing an SOP statement also for I, right? And I is assumed at this place. So in the second run, first x was initialized, okay, then a static block should be executed. And when a static block is executing, static blocks gets loaded at this place, and it then inside the static block, control flows from top to bottom approach. For it is at this statement, so it prints here instance initialization block 1 in A. Then control comes to the next statement. Next statement is a memory allocation, int I. So I memory is a local variable, so it allocates the memory of I in the corresponding stack frame, and here it prints 99 and then prints here. Then control is the next here and it prints 99, right? Then control comes to the next state. Here x should be printed, and the x value is already initialized, and that is 10. It prints here 10. Now when you come at this point, y memory is now 0 because y is not initialized yet. Y is actually here, the hard-coded value of y is here, but the control has not reached at this point and it is not initialized with 20. So still the value of y is 0. So what happens at this point is, when class is initialized, and when all the static variable memory gets allocated, and when all that variables initialized with default value, then these variables, until it completes the second run, these variables with the default value is not able to read. You cannot read that variables, and that state is called as read indirectly and write only. Means the variable which is just allocated the memory and which is initialized with the default value, not initialized with the hard-coded value, or it has not completed the second run, at that time the variable you cannot read, and this state is called as read indirectly and write only. Means you can just write the variables, you can write some value to that variables, but you cannot read those variables directly until the control comes into this point in the next run. So at this point, when control is here with x, at that time this x is already initialized with 10, so you can read it directly, no problem, because this state is over at that time, and that time you can read and write. Once this completion is over, once this initialization is over in the second run, then this is in read and writing mode. Means you can read the variable or you can write it, but before completing this step, then the variable is read indirectly and write only. Means directly you cannot read. So when control comes at this point in the static block, first static block, x variable is in read and writing mode, but y is not still in read and writing mode, it is still in read indirectly and writing mode. So here if you try to access this variable here, you get an exception, compile time exception here, saying illegal forward reference. This gives a problem, illegal forward reference, because the writing mode of this y is still not completed. So you cannot read it directly, it is a compilation fail, illegal forward reference. So you understood here very clearly what is illegal forward reference. Illegal forward reference is when a class is initialized, means the JVM searched all the class for all the static variables, and all the static variables memory gets allocated, and that is initialized with default value. And before completing the second run, before it executes this statement once again, if you try to read this variable value, at that time the variable is read indirect and write only mode. So in that case you cannot read it. If you try to read that variable again, then it gives a illegal forward reference. But at that time what you can do directly is you can write a value in that. This variable can write a value, but it cannot read. So this statement gives here a illegal forward reference. So to overcome with this problem, what you can do is you can write it like this: SOP statement of a dot y. With the class name you can read. Now it is not giving any problem, and it will print here 0. It is fine, no problem, it is 0. Right. This is to avoid the illegal forward reference. You can read that forcefully with the class name, not directly, indirectly you are reading. Right. Now the control is, this is over. Illegal forward reference is this, and illegal forward reference to avoid, you can write here directly. You are not reading directly, you are writing with the class name, and you can read it. So now control comes at this point, and x again gets initialized with 99. Now it is not 10, it is 99, right? And y also initialized with 88. So this is also fine, you can do it, because the variable is still is in writing mode. Directly you can write, but you cannot read it directly. So now writing is not giving any problem, you can make it 88. Now the y value is 88. So this is the execution of first static block, step number 7. Now control comes into the step number 8. This is step number 8. Y should be initialized with 20. So y is again reinitializing, which was 88. Again it is reinitializing with 20 for this point. Okay, once this is also over, just initialize with 20. Now y value is 20, and that is over. Then control goes to next static block, that is step number 9, and step number 9 again flows top to bottom approach. This block also executes in top to bottom approach. And once this block execution is over at step number 7, y is initialized till 88. At that time control comes into this next y should be initialized with 20. When control comes out from the static block to y and y initialized with 20, at that time immediately these blocks get destroyed. Right? It is no more there in stack memory, or it is not having any stack frame now. So next what happens is when control y is initialized with 20, this is over, then control comes to the next static block, that is step number 9, and it starts from execution from top to bottom approach. So assume here again I will take one more variable, int I is equal to 88, and print the I, right, printing I. Now when this block starts execution, at that time this was already destroyed and this is again loaded. This is not the previous stack frame, this is a new stack frame generated here, and it starts executing this. So here it prints again, say static initialization block 2 in A, and this is now control comes at this point. I memory should be allocated. It is not the previous I, it is a new frame, so new I memory is allocated and the value of I is 88. Now control is here, it has to print the I value, and I value is 88, printing, right? So once that is over, then control comes into X. At that time X value is 99, so it prints here 99, and print the Y value is at that time 20, so it prints here 20, right? Now it prints here, let's say 20. Now control is at this point, X should be reinitialized with 101, so this is 101, and Y should be reinitialized with 102, so Y is now not 20, it is 102. That is over. When this execution of this stack frame is over, then this complete memory again gets destroyed immediately. Then this execution, this is completely done, and finally the X value is 101 and Y value is 102. This was done because of this. When you will say here a dot show, at the time of that A class should be loaded. At the time of loading the A class, this operation is done. So what are the steps we have seen? In the first run, JVM initializes, JVM goes through the entire class and finds out what are the static members available, and at that time it allocates the memory for all the static variables and initialize the memory, allocate the memory and initialize that with the default values. That is called as class initialization. Once the class first run is done, class initialization is over, then again JVM goes through the entire class again and initializes the hard-coded value to the static variable and executes the static block also in the second run. So first time 10 will initialize to X and first static block will execute, 20 will initialize to Y, second static block will execute, and that is done and class loading is over. So this is the static control flow. The important point you have to notice here is in the next run, when JVM goes through after initializing the class, JVM has to execute the static variable and execute blocks also, static variable and static blocks also. But in first run, JVM just allocates the memory for all the static variables and initialize them with the default values. In second run, when JVM is initializing memory, initializing the value for static variables and executes the static block also, at that time all the static variable and all the static blocks has to execute, and that should be done in the same order how it appears in the source file. Means if the static variable is coming first, then static variable will be initialized first, then static block is coming, static block will execute, then again another static variable is coming, another static variable will be initialized, another static block is coming, that static block will be executed. And illegal forward reference, which is actually very important at this point. Illegal forward reference is when at the first run JVM just allocates the memory for all the static variables and initializes that with the default values. At that time the variables are in read indirectly and write only mode. You cannot read that variable directly, and if you try to read that directly, you are going to get a illegal forward reference because that was not initialized with the actual value till now. So to avoid with that illegal forward reference, what we are doing, we are not reading that directly, we are reading that with the class name, that is a.y. Now it is not giving any problem, and this gives here the output as the default value, that is 0, right? So this is the class loading is over. Once the all this complete second run is also completed, then the class loading is over. Now JVM will come here and it is a dot show. Now it calls the show method. When it calls the show method, on top of this stack frame, say I have, at that time this actually got destroyed. All these are destroyed here, nothing is there in that. This is destroyed, and what JVM will do is so this is the memory, and now class loading is over. So JVM tells here, okay, class loading is over, and now it calls the show method, and on top of this another stack frame will be generated, and here show function is loaded. This is show function is loaded. Now inside the show function, control flows again top to bottom approach, and first statement you have here show in A, so it prints here show in A. Now it has to print the x value and y value. What is the x value now? X value is now 101 and y value is now 102. So it prints here 101 and 101 and 102. So this is the control flow of static control flow of a class. When you load a class, JVM has to check the class in this way, and so this you can say is now 10 because this is it has called the main method from this point, right? And now main method is show method execution is over, and show method gets destroyed, and then control returns back to the main method execution is also over. So JVM deletes all this memory, and the memory will return back to the operating system, and JVM gets terminated, right? So this same only now let us see with a example with Eclipse and how it works. So here I have a class A. Class A is having a static variable 10 and one static block. In a static block, it is a static block 1, and say in A and X I am printing, Y also I am printing, but Y I cannot print directly. If you do like this, then it is a compilation fail. This is here gives illegal forward reference. So this is commented, and I am reading that by using a.y, right? Now okay, here you take a local variable also, say int I is equal to 99, and print that I also. You remember that there is a local variable in I, so I'll say here it is I is this, right? So local variable I is printed, and then X is reinitialized with 99 and X is reinitialized with 88. Sorry, Y is reinitialized with 88. So this static block is this. Now I have another variable y is 20, hardcoded value is there. Then you have a static block. In that static block also I'll take a, say it is int again I, another variable, and this is 99, and again you print I, right? And you are accessing X and you are accessing Y. At this point, X and Y you can access directly because that now this X and Y is read and writing mode. So again X is reinitialized with 10 and 20, 101 and 102, and this is show method, which is giving the final value of X and Y. So how this execution flow will work here is when you will say here a.show, JVM starts and JVM calls a.show. But before calling a.show, a class has to be loaded. When it is loading a class, JVM will search the entire class for all the static variables. So first static variable is X, right? X memory is allocated somewhere in the stack, and X get 0 default value. Then it checks, okay, another static variable block is there, so this is 2. Then it checks another static variable is there, so this is 3, this is Y memory also allocated, and this is having 0 default value. And then one more static block, okay, fine, and so this is 4, static block 4, and then you have a show method, of course, right? It has a show method, fine. Now when this is the first run is over, at that time you notice here all the variables here currently we are having X and Y, and X and Y are the static variables, but these variables are having actually hard-coded values 10 and 20 here. But still, when JVM allocates the memory for any static variables, first time it gets the default value, and this stage is called as read indirectly and write only method, right? Read indirectly and write only mode. So now this is over. And next stage, when JVM again starts and again JVM goes through the entire class, then x should be initialized with 10. X value is 10 now, and then it starts executing the first static block. So output should be static initialization block 1 in A it has to give, and then it has to allocate a memory for I, but it is in local scope. Okay, this I is in local scope in the corresponding stack frame, and I value is 99. Then prints the value of I, it is 99, and prints the value of so this is you can say here it is 5th, and this is 6th is going to start execution, right? So I is done, and it comes here, I value is printed. Okay, then it comes here and prints the x is equal to, this is currently at that time x value is 10, so it is 10, x prints 10. But why directly you cannot read? If you try to read here you are going to get a illegal forward reference. To overcome with this problem, what we did, we are reading that forcefully and indirectly we are reading, and we are saying here a.y. a.y at that time is 0, so here it prints y is equal to 0, right? Then x gets reinitialized, and x value here will be 99, and y gets reinitialized, y value will be now 88. Now when y is initialized, y this stage is over, now y you can read and write, right? Okay, fine, this is done. When static block first execution is over, then it comes at this point, it is 7, and in 7 y reinitialized with 20, right? Then this is 8, static block starts execution, and it prints static initialization block 2, and another local variable I, again I is 99, and I is printed. Then x and y value should be printed. X at that time is 99, so x is 99. Y value at that time is 20, it prints here 20, right? Now when that is also over, then at last x and y should be initialized with 101 and 102. So x gets here, now it is not this, it is 101, and y is not 20, it is 102, and this static block execution is also over. Once this execution block is over, then execution of the class is, loading of the class is also over, and then it calls the show method, right? Then it calls from here show method, and show method gets loaded. So when we will say here show, then only the class loading is done, and this all the operation is done, and after that finally it calls here the show function. When show function is called, at that time show function is going to print show function, and x and y is going to be printed. At that time x value here it is 101, and y value is 102, so it here gives the output as show in A, and x value is 101 and y value is 102. So this should be the output. Now let's execute this program and see the output, how it right. Now if I just run this program and you see the output, first here a static block in A gets printed, right? A static block in A gets printed. Once a static block is over, a static block in A is printed. Once it is over, actually till that time, when the static block is executing, till that time x memory is already allocated and it was initialized with 10, right? So then it is coming in the next run, it is coming into this static initialization block 1, and the static initialization block being printed. And I is a local variable, so it got the I value is 99 here, and I is printed, that is also done. Then x, at that time x value is 10, already this statement is executed, so x value is printing here 10. Then y directly you cannot read, so we are reading indirectly with the class name. At that time y value is 0, so it is printing here y value is 0. Then x is reinitialized with 99 and y is reinitialized with 88. That is done. Once that is done, y again gets initialized with 22. Done. Then control has to come into this place, and it is static initialization block 2. That is over. Then again another I, which value is 99, and it is printing here 99. At that time x value is at that time here initialized with 99, so it is printing here 99. And y value is initializing with 88, sorry, y gets initialized. Okay, at this place y got initialized again, so y is printing 20. Once this execute, this till this is done, class loading is over and everything is done, then it calls finally the show method. Show method is printing this, but actually it is not done till now. Here at last in this block we have again reinitialized with x is 101 and disinitialize y with 102. So this is the static control flow of a program. Thanks for watching my video. Please subscribe for more videos.